Okay, so you've brought us an ambitious one today.
Yeah,
Starlink.
absolutely.
We've got a collection of articles and research here,
Yeah,
and it's clear that you're trying to really get a handle on, what this global satellite internet project is all about
right.
from SpaceX.
Absolutely.
So for anyone listening who's curious, what is Starlink at its core?
Well, at its core, Starlink is really about creating a worldwide internet network
Okay.
using a massive number of satellites
Okay.
orbiting relatively close to Earth
Hmm.
in what we call low Earth orbit.
Okay.
And the idea is to deliver affordable internet, particularly to those areas that currently have poor or no connectivity.
All right. And when we say massive, we mean it right.
Absolutely.
As of late March 2025, there are over 7,100 Starlink satellites circling our planet,
Yeah.
with over 7,100 of those up and running.
Wow.
And what's really mind-boggling is the sheer growth.
Yeah.
Elon Musk initially talked about around 4,000 satellites back in 2015, and now their long-term vision stretches to a potential 42,000.
Wow.
It's just a huge leap.
It really puts things in perspective when you consider that up until November 2022, the total number of all satellites ever launched in human history was only around 14,450,
Okay.
with roughly half of those still active.
Wow.
So Starlink's ambition is on a scale we've just never seen before.
Yeah, one company poised to become the dominant presence in Earth's orbit.
Exactly.
So with this deep dive, we really want to get to the core of Starlink. Explore that exciting potential.
Yeah.
I mean, that promise of connecting the unconnected is huge.
It's massive.
But also explore the very real concerns that are being raised,
Yeah.
particularly when it comes to astronomy
Right.
and the long-term health of our planet's atmosphere.
Absolutely.
So you've given us a really wide range of material to consider here.
We have.
From the nuts and bolts of this technology to some pretty profound questions.
Yeah.
So where do we even begin to make sense of all this?
Perhaps the best starting point is something tangible. Something that you yourself or anyone looking up at the night sky might actually witness.
Ah, yes, the now famous stream of pearls.
Exactly.
Tell us about that.
Because Starlink satellites orbit at a relatively low altitude,
Okay.
around 342 miles up. They can be surprisingly visible
Yeah.
to the naked eye,
Yeah.
especially in the days right after a launch.
Right.
They appear as a train or a string of bright lights moving steadily across the night sky.
I've seen some incredible photos and videos of these formations.
Yeah.
And
It's quite a sight.
it is. It makes you wonder, if someone were just looking up
Right.
and had no idea what they were looking at,
Yeah.
what would they even think?
Right. It is visually striking, but
Yeah.
as your sources highlight,
Yeah.
this visibility isn't universally appreciated.
Okay.
While some might find it beautiful,
Mm-hmm.
it presents a significant challenge for both optical and radio astronomy.
Okay. So it's more than just a pretty light show. It's got real implications
It does.
for how we study the cosmos.
Absolutely.
So let's delve into that a bit.
Sure.
Who is Starlink ultimately aiming to serve with this vast network?
Well, the fundamental goal is to provide internet access
Okay.
to regions where traditional infrastructure is unreliable or simply doesn't exist.
Okay.
Starlink emphasizes this on its website,
Yeah.
stressing its potential to connect people to vital services like education, healthcare, and crucially, to provide essential communications during natural disasters and emergencies.
Right. And we've seen some compelling real-world examples of this playing out.
We have.
Ukraine and Tonga come to mind.
Absolutely. In Ukraine, following the Russian invasion, Starlink terminals became a vital lifeline for communication
Right.
when other systems were heavily disrupted.
Yeah.
Thousands of these terminals were deployed,
Okay.
providing essential connectivity
Wow.
for everything from government operations to civilian communication. Similarly, after the devastating volcanic eruption and tsunami in Tonga,
Yeah.
Starlink offered crucial internet access to the affected population,
Right.
particularly in those remote island communities.
Yeah. It's genuinely hard to argue with that kind of positive impact
Yeah,
in those critical situations.
right.
But let's step back in time a bit and look
Okay.
at the genesis of this project.
Sure.
January 2015, wasn't it?
Yes, that's when Elon Musk publicly announced the project,
Okay.
although the Starlink name came a bit later.
Okay.
He spoke about a long-term vision of essentially rebuilding the internet in space
Wow.
and mentioned initial filings to place around 4,000 satellites
Okay.
in low Earth orbit.
And that initial figure seems to have multiplied pretty quickly.
Well, several factors contributed.
Yeah. What fueled that exponential growth and ambition?
Partly, it was driven by the sheer potential of the global internet connectivity market.
Okay.
And undoubtedly, it also ties into Elon Musk's broader ambitions,
Yeah.
including the long-term goal of Mars colonization, which would require a robust communication infrastructure. The FCC has now granted permission for 12,000 Starlink satellites.
Wow.
And SpaceX has even filed for authorization for up to an additional 30,000.
Yeah.
It's an increase of truly staggering proportions.
Okay, so that leads us to one of the major areas of concern that your sources repeatedly highlight. The impact on our ability to observe the universe astronomy.
Right.
Let's start with optical astronomy.
Okay.
What's the fundamental problem?
Well, as we mentioned, the initial launches surprised many astronomers with just how bright the satellites appeared. They started showing up as streaks of light across long exposure astronomical images.
Right.
This is a significant problem, particularly for highly sensitive next-generation telescopes like the Vera Rubin Observatory, formerly known as the LSST, which is designed to survey the entire visible sky in unprecedented detail. These satellite trails can obscure faint celestial objects and fundamentally corrupt the valuable data astronomers collect.
Right.
It's like trying to take a pristine photograph and having someone repeatedly draw lines across it.
So it's not just a minor annoyance.
Yeah.
It's a significant impediment to scientific discovery.
Precisely, the American Astronomical Society likened the impact to light pollution.
Okay.
Suggesting that the cumulative diffuse reflection of sunlight from these vast numbers of spacecraft could potentially double or even triple the natural faint glow of the night sky. That's a massive increase in what astronomers call sky glow, making it harder to see the faintest and most distant objects in the universe.
And SpaceX has made some attempts to mitigate these issues, right?
They have?
I recall reading about visors and other modifications.
Yes. Newer Starlink satellites are being equipped with visors. Think of them as sunshades, designed to reduce their reflectivity and therefore their brightness, as seen from Earth. It's a positive step. And the latest generation also incorporates darker coatings. However, the sheer and growing number of satellites still raises significant concerns within the astronomical community about the overall cumulative effect on our ability to observe the night sky.
Okay, so that's optical astronomy.
Right.
Now, the visual disruption is one thing. But your sources indicate that radio astronomy might face even more profound challenges from these satellite constellations.
Why is that?
Well, radio astronomy relies on detecting incredibly faint radio waves emitted by objects in the universe. Signals that have traveled vast cosmic distances. For decades, radio astronomers have painstakingly worked to protect specific, very narrow frequency bands from human-made radio interference. This involves complex international regulations and the careful allocation of the electromagnetic spectrum.
So it's already a very tightly controlled and managed environment.
This invisible world of radio frequencies, the fundamental problem with Starlink and similar large satellite constellations is that their primary function is to continuously beam down radio signals to provide internet access.
That's right.
So even with regulations dictating which specific frequencies they can use, the very nature of radio waves is that they can spill over into adjacent frequencies. Think of it like sound bleeding from one room to another, even if the main sound source is in a different space. These spillover signals can then interfere with the incredibly sensitive receivers used by radio telescopes. So even if they're not directly transmitting on the exact frequencies astronomers are listening to, there's still a significant risk of contamination.
Precisely.
One potential mitigation strategy I know that's been discussed is the idea of satellite operators temporarily turning off their transmitters when they are directly overhead of major radio telescope facilities. However, as one of your sources points out, even with the best intentions, a complete and perfect cutoff of all interference is likely to be physically impossible due to the way radio waves propagate. So this constant background noise from thousands of satellites has the potential to significantly degrade or even drown out
Yeah.
crucial radioastronomical observations.
Absolutely.
This brings up an interesting point about the orbits themselves.
Hmm.
If these lower orbits are causing visibility issues,
Right.
wouldn't placing the satellites in higher orbits be
Right.
a better solution overall?
It's somewhat counterintuitive,
Okay.
but actually from the perspective of optical astronomy,
Mm-hmm.
lower orbits are generally preferred.
Really?
While satellites in lower orbits are closer and thus can theoretically appear brighter,
Mm-hmm.
they also move across the sky much faster. This faster movement means that when astronomers take long exposure images,
Yeah.
the resulting satellite streak is fainter and shorter
Interesting.
because the object doesn't linger over the same pixels on the detector for as long.
So a fleeting dimmer streak
Yeah,
is less problematic than a slower, brighter one
exactly.
that lingers in the field of view.
Your source mentions that OneWeb, another satellite internet provider,
Right.
opted for higher operational altitudes,
Okay.
which was actually a disappointment to some optical astronomers
Interesting.
because of the slower movement
Right.
and potentially brighter, longer trails.
Wow.
SpaceX, on the other hand, has been more inclined towards lower operating altitudes, although, as we'll discuss, this choice introduces other challenges,
Right.
particularly concerning the increasing risk of space debris.
Yeah. The ever-present concern about things colliding in space.
Absolutely.
That was another big theme in your materials.
Yes.
Tell us a little more about that.
In 2019, there was a widely reported incident where the European Space Agency's Aeolus satellite
Mm-hmm.
had to perform an emergency evasive maneuver
Oh, wow.
to avoid a high probability collision
Goodness.
with an early Starlink satellite.
Oh, wow.
The predicted probability of collision was significantly above ESA's threshold for taking action.
Wow. That sounds like a potentially catastrophic near miss.
It was a stark reminder of the growing congestion in low Earth orbit.
Yeah.
Then in 2021, Hugh Lewis, a leading expert in the field of space debris,
You okay?
made a significant assessment.
Mm-hmm.
He concluded that Starlink had become the primary source of collision risk
Wow.
in low Earth orbit.
Okay.
His computer models at that time indicated
Mm-hmm.
that Starlink satellites were involved in approximately 1,600 close encounters,
Wow.
defined as being within 0.6 miles
Goodness.
with other spacecraft
Yeah.
every single week.
That's a lot.
That represented about half of all such close approaches.
Mhm.
And alarmingly, this number is only projected to increase
Yep.
as the total number of Starlink satellites in orbit continues to grow.
So it's not just about the risk of Starlink satellites colliding with each other.
Yeah.
It's the broader implications
Right.
for the safety of all satellites,
Yeah.
even the International Space Station.
Absolutely.
Now let's shift gears a little bit and talk about
Okay.
the end-of-life plan for these thousands of satellites. I mean, they don't just stay up there indefinitely, do they?
No, they don't. SpaceX has stated a plan to deorbit their Starlink satellites
Okay.
after an estimated operational lifespan of around 5 years.
Okay.
The process involves using the satellite's own thrusters
Mhm.
to steer them back down into Earth's atmosphere,
Right.
where they are designed to burn up completely.
Okay.
From the perspective of preventing the long-term accumulation of space debris,
Mm-hmm.
this is generally considered a responsible approach.
So that's a positive aspect, at least in terms of mitigating the space junk problem.
Yeah.
However, your sources also brought up a potential environmental downside, right, to this deorbiting process itself.
Yes.
Something related to the atmospheric impact of all that burning material?
Yes, this is an area of increasing concern and active research
Okay.
among some scientists.
Yeah.
As these thousands of satellites re-enter and burn up in the upper atmosphere,
Mm-hmm.
they release their constituent materials.
Right.
Research conducted by Aaron Boley has raised concerns
Okay.
about the significant amounts of aluminum oxide,
Right.
also known as alumina,
Mm-hmm.
that will be produced from the aluminum used in the satellite structures.
Okay. And why is the introduction of this alumina
Right.
into the upper atmosphere a cause for concern?
Alumina particles are known to have the potential to contribute to ozone depletion
Okay.
in the stratosphere.
Right.
Furthermore, Boley's research suggests
Mm-hmm.
that these particles could also alter the atmosphere's ability to reflect solar radiation back into space,
Okay.
a property known as albedo.
Mm-hmm.
He warns that this could inadvertently lead to a form of uncontrolled geoengineering.
Unintended geoengineering. That sounds quite alarming.
Indeed.
That's not a path we want to stumble down unknowingly.
Right. Karen Rosenloff, an expert in atmospheric chemistry at NOAA,
Okay.
has also voiced concerns about the potential effects
Mhm.
of this influx of metal particles.
Right.
in the upper atmosphere.
Yeah.
Drawing on her extensive knowledge of modeling intentional geoengineering strategies,
Wow.
the scientists emphasize that these fine particles could persist in the upper atmosphere
Okay.
for extended periods, potentially years.
Right, and it's not just about the potential chemical reactions. No, it's
Yeah.
the sheer volume of material being introduced,
Yep.
even if individual satellites aren't that massive.
That's right. While the estimated daily reentry mass of first-generation Starlink satellites is around 2 tons,
Okay.
compared to approximately 54 tons of natural meteoroid material
Right.
that enters our atmosphere daily.
Okay.
The crucial difference lies in the chemical composition.
Okay.
Meteoroids are primarily rocky material, composed largely of oxygen, magnesium, and silicon,
Okay.
with very little aluminum.
Right.
Starlink satellites, in contrast, are predominantly made of aluminum alloys.
Okay.
This means we are introducing a substantial amount of a specific substance into the upper atmosphere in quantities that are not naturally occurring.
So it's that potential for these seemingly small daily additions
Right.
to have significant long-term cumulative effects
Exactly.
that really worries researchers.
Precisely the analogy to the early understanding of fossil fuel-induced climate change is quite striking.
Yeah.
Just as we initially underestimated our capacity to alter the oceans with plastic pollution
Right.
or the atmosphere with carbon emissions,
Yeah.
there's a growing concern that we might be making a similar oversight
Right.
regarding the long-term consequences of burning thousands of aluminum-based satellites in the upper atmosphere.
It's worth noting that SpaceX has not publicly commented
They have not.
on the specific atmospheric concerns raised by the scientific community. Right.
That silence in itself perhaps speaks volumes.
Yeah.
Let's pivot slightly and talk about the technology itself.
Okay.
You mentioned V2 Starlinks.
Yes.
What are the key upgrades and differences in this next generation?
SpaceX began launching the V2 mini version of the Starlink satellites
Okay.
in February 2023 as a precursor to the full V2 design,
Okay.
which is anticipated to launch on their larger Starship rocket.
Right.
Once that becomes fully operational, the V2 minis represent a significant step up in both size and capability
Okay.
compared to the first-generation satellites. They feature more powerful ion thrusters for maneuvering,
Okay.
refitted and more advanced antennas, and the ability to utilize E-band backhaul for communication,
All right.
which dramatically increases their data capacity.
Right.
Think of it like adding many more lanes to a highway,
Okay.
allowing for a much greater flow of data.
So they're essentially more powerful,
Yes.
more efficient,
Yeah.
and can handle a much larger volume of data traffic. That's exactly.
And the full V2 satellites, once they're deployed, are expected to have even greater capacity and the capability to provide direct-to-cellular service through a partnership with T-Mobile.
Exactly.
This has the potential to revolutionize mobile phone connectivity
Yeah.
in remote and underserved areas, allowing people to connect directly to satellites without the need for specialized hardware.
Exactly.
It really highlights how rapidly this technology is evolving.
It does.
We also saw a dramatic example of how space weather
Yeah.
can unexpectedly impact these satellite constellations, didn't we?
We did.
The geomagnetic storm event in February 2022.
Yes, that was a significant real-world demonstration
Yeah.
of the vulnerabilities of these low Earth orbit constellations.
Okay.
A powerful geomagnetic storm caused a dramatic and unexpected increase in atmospheric density
Right.
at the relatively low altitudes where a recent batch of newly launched Starlink satellites were positioned.
Wow.
This increased atmospheric drag
Okay.
prevented a large number of them, up to 40,
Goodness.
from reaching their intended operational orbits,
Right.
leading to their premature and uncontrolled re-entry
Wow.
into Earth's atmosphere.
So it underscored the inherent risks
It did.
of operating at these lower altitudes
Right.
and the potential impact of space weather events
Yes.
on the long-term viability of
Right.
such large constellations.
Absolutely.
Okay, so we've covered an awful lot of ground here.
Yeah.
Starlink presents a truly compelling vision for global internet access with some, very tangible benefits
We have benefits.
that we've already seen
Right.
in those emergency situations.
Absolutely.
However, it also raises some significant and complex challenges
It does.
when it comes to, our view and study of the cosmos,
Yeah.
the growing safety concerns in Earth's orbit, and potentially long-term
Right.
and largely unknown impacts on our planet's atmosphere.
It really does.
I mean, the sheer scale of this project, with the potential for tens of thousands of satellites in orbit,
Right.
means that both the potential benefits
Absolutely.
and the potential risks are amplified to an unprecedented degree.
Right.
There are clearly very different perspectives
There are.
on whether the advantages ultimately outweigh the costs.
Absolutely.
So here's a final, perhaps provocative thought for you to consider.
Okay.
Given this rapid and ongoing expansion of
Right.
these massive satellite constellations,
Mm-hmm.
what do you believe is the single most critical aspect that demands the closest monitoring and robust international collaboration? Is it the potential for a fundamentally altered night sky
Okay.
and its impact on our understanding of the universe?
Right.
Is it the increasing risk of collisions and the long-term sustainability of activities in Earth's orbit?
Right.
Or is it the largely uncharted territory of the long-term effects of atmospheric pollution? From the deorbiting of thousands of satellites made of materials not naturally abundant in those atmospheric layers,
Right.
what kinds of trade-offs, if any,
Yeah.
are ethically and practically acceptable in the pursuit of this global connectivity?
Right.
It's a complex web of interconnected implications.
It really is.
And your continued engagement with these questions will be crucial
Absolutely.
as this technology continues to develop and reshape our world and our view of the wider universe.
It's fascinating, isn't it?
Thanks for taking this deep dive with us.